There are often many ways one can isolate a variable. This video shows 3 examples of solving the same equation, but with 3 different approaches. There's not a correct way, where all other methods are wrong, but there often is a strategy that is faster or easier. It is good to be familiar with different approaches so you can deepen your understanding of math processes and can adapt your steps for solving equations based on the type of equation given. Here we have the same equation written out 3 times, and we'll see 3 different methods to solve it. The first method that is used is SAMDEB, adding a term to each side. So plus 2 is added to each side, and we get root x plus 1 over 3 equals 11 over 3 plus 2. Then the fractions on the right are added together. A common denominator is used so that that can happen. And at this point we see that both sides have a denominator of 3, so if we multiply each side of the equation by 3, the denominators will cancel, and we have root x plus 1 equals 17. We can subtract 1 from each side, and then square the left side and square the right side to get x equals 16 squared, which gives us 256. With the second method, the approach is to multiply each term by 3 immediately, clearing the denominator and giving us root x plus 1, and then getting negative 6 and 11 on the right-hand side. Like terms are gathered to get root x minus 5 equals 11, and then we add 5 to each side to get root x equals 16. Squaring each side gives us 256. The last method that's used is to separate the first fraction into root x over 3 plus 1 over 3. Then every term is multiplied by 3 to clear the denominator of 3. We get root x plus 1, because 3 cancels with 3, minus 6. Negative 3 times 2 gives us negative 6. 1 times 1 gives us 1. Negative 6 over 1 is negative 6. Then, like before, we gather like terms, and we can add 5 to each side of the equal sign, giving us root x equals 16. Squaring both sides gives us 256. We see the same answer using 3 different methods. We have a new equation now, and again 3 different methods will be used. We can see that 5 and 10 are denominators that have a common multiple of 10. 5 can go into 10, 10 can go into 10. So if we multiply each term by 10, we can clear the denominators. So 10 times 10e will give us 100e. Then 10 times 2e over 5. 10 divided by 5 will give us 2. So the denominator is gone. And then with the next term, 10 divided by 10 will give us 1. So we're left with e minus 3 in the brackets. Now everything is over the denominator of 1, so we don't need to write that denominator. We can multiply 2 times 2 to get 4, and then multiply e minus 3 by the negative 1 out front to get negative e plus 3. And then we will subtract negative 3e from each side to get 97e equals 3 and divide by 97. The next example takes the first term on the right-hand side and multiplies by 2 so that we have a common denominator of 10. Since we have a common denominator of 10, we can write everything on the right-hand side all over 10, and we can simplify in the numerator. 4e minus e gave us 3e. Then we can multiply each term on the left and the right by 10 to clear the denominator on the right-hand side. We get 100e equals 3e plus 3. We'll subtract 3e from each side. We get 97e equals 3, and when we divide by 97, we get 3 over 97 for e. The last example breaks the final term up into negative e over 10 plus 3 over 10. Again, notice the effect of the negative sign out front of that fraction. Because we have 3 terms now on the right-hand side and we have separated the e from the 3, we can gather like terms. The 4e over 10 term and the minus e over 10 term can be grouped together to give us 3e over 10. And then we can subtract 3e over 10 from each side of the equal sign. We get a common denominator of 10, and we can subtract the e terms to get 97e equals 3. Then we divide by 97 to get e by itself. We have 3 over 97. So we've used 3 different approaches. Finally, the last example shown is one in which there are decimals with every term. This often happens with equations when we're dealing with money. So the first method that's used is to multiply every term by 100 so that the decimals are taken care of. They move 2 places to the right and we get 25y plus 133 equals 8. Then we can subtract 133 from each side. We get 25y equals negative 125, divide by 25, and we're going to get y equals negative 5. In the second method, the approach used is to subtract 1.33 from each side of the equal sign, giving us 0.25y equals negative 1.25. Then 0.25y is divided by 0.25 to get y by itself, and we have y equals negative 5. The third method is to divide every term by 0.25 so that y becomes 1y immediately. We get y plus 5.32 when we divide equals 0.32 when we divide. Then we subtract 5.32 from each side of the equal sign to get y by itself, and y equals negative 5. 3 different methods, the same answer.